you started your career in 1980 as a
Correct.
bench technician repairing instruments at the component level. How has that ground up kind of understanding of hardware influenced your approach to things like high level industry 4.0 systems?
It's funny. I have thought about that a bit. And every time you mentioned me teaching classes, every time I start my class off at the beginning, I go through the syllabus and I talk a little bit about my path and how circuitous it was and how I got where I am. And, people ask, hey, do you think you'd change something? And in this case, I don't think I would. I don't know if I'd do it any other way. You hit the nail on the head. It comes down to having such a good granular low level foundation starting in electronics, being a bench technician and understanding why instruments and PLCs and IO cards, why they work, not just that they work, but why they work. And then being able to add the elements on top of that. I think that is um, crucial to how I've done what I've done. It didn't start that way, quite honestly. It was a little snafu in paperwork. I was originally supposed to be in the Bachelor of Science EE program at the University of Hartford originally, and I had gone for the orientation, paid my orientation fees, paid the registration fees, signed up for my classes. What comes in the mail is a bill without my financial aid. So
Uh,
after a little bit of rigmarole, the paperwork snafu, again, for your listeners, this was before email. This was before
right.
the internet.
Right.
So they would send a letter. I never got the letter. Anyway, at the end of the day, I didn't get the financial aid, so I had to pivot. I knew what I had in the bank. I went from a bachelor's program to an associate's program in electronics. And again, I think I was blessed by having that snafu because it really changed how I looked at things and why. It helped me build the foundation from a hardware standpoint and build it from the ground up and understand again not just the that it works, but why it works.
Right. With that 44 years of experience, 45 years of experience, right? Wow. Um, in well, I guess you could say it's in process and automation control.
Correct.
Um,
Yep.
yeah, is there one technology that you once thought, oh, that's just a passing fad that ended up becoming an industry standard, or has there even been something that, oh, it's the next best thing that you've seen that never really quite fulfilled its destiny?
Interesting question. So far, so far, everything that I've encountered has had a learning curve. Don't get me wrong. Everything new, you have to figure it out. But again, it's kind of a building block structure.
Sure.
Thinking about the development and evolution of network systems is kind of maybe one of those things. You go back and think about where we've been and how technology has changed so rapidly. You think about ArcNet, token ring networks,
Mm-hmm.
control net, device net. A lot of those things have come and gone. And Ethernet is kind of here to stay. And over the last, again, I've been doing this for 40 years, but 45, but I actually have to say the last 10 years has probably been the largest portion of aggressive growth.
Yep.
If I had to sound cheesy, maybe, and say, and I know this is a common answer nowadays, but perhaps AI. Um, when I
Right.
first started understanding what that is, you talked about my MBA in business with data analytics, but the master's degree I had before that was in modeling and simulation. So there's a lot of statistical analysis, modeling. You understood what AI was, you understood what machine learning was, and I'm sure a lot of your listeners know and viewers know, but AI was actually a coined phrase in the 50s. It's not a
Right.
new concept. It's
Right.
something that is based in math. So while it may sound a little cheesy in saying, hey, AI is a passing fad, when I first heard about it 3 or 4 or 5 years ago, in the context that we understand it today, again, it's been around forever.
Mm-hmm.
But as I understand it today, it was buzzwords. People were just throwing it out there. What I thought was a passing fad, obviously, it's here to stay, and it's probably one of the biggest things I know, the ISA conference, the CSIA conference, every place I go and present at, it is a hot topic. Everybody's talking about it. So
Sure.
passing fad, I'm not sure. Maybe the network structures were probably the only thing I could say that with.
Right. Yeah, that when you mentioned that about the networks, it made me think of at our old company, we used to actually have a publication called Industrial Networking, which covered a lot of those things that you had talked about. But then ultimately, it just came down to we're just covering Ethernet all the and so the publication became obsolete essentially
Yeah,
because like there's only one thing to cover because that's what everyone uses. Yeah,
right.
yeah. Everything
Yeah.
else had kind of flown by the wayside. But do you think with artificial intelligence, I mean, obviously the benefits seem to be limitless. Uh, But in my understanding at least, isn't it really just processing? I mean, isn't it just the ability to run hundreds or if not thousands of processors in order to calculate something much faster than we used to be able, we couldn't with our brains or that a single computer could do.
No, absolutely. NVIDIA right now, everybody knows, is kind of going through the roof with the co-processors and the graphic processors and everything like that,
Right.
the GPUs. The reason why AI is what it is today is essentially processing speed, processing power, its memory capability, storage capability, whether it's cloud or local, and again that processing power of GPUs and what's available. Being able to do parallel processing and cloud computing has enabled and opened it up. The big thing is, if you think back of the whole Industry 4.0 thing and why it became Industry 4.0, Industry 3.0 was the implementation of computers on the floor.
Mm-hmm.
So if people actually did that in their factories and they actually put computers and started doing data acquisition back in the late 80s, 90s, 2000s, you
Mm-hmm.
have all of that data that used to make some nice, pretty charts and graphics. But now, with the analytical tools that are available, you can use that data. Don't get me wrong, it's not an easy thing because back then there was no rhyme or reason of how you structured the data, how you
Right.
put things away, where you put it.
Yeah.
And that's one of the major pitfalls of AI is you have to have clean, structured data to be able to
Mm-hmm.
analyze it. So, um, yeah, I think we're here where we are because it was kind of okay, we have the math, we have the ability, but now we have the technology to be able to produce the information.
Now data centers are springing up everywhere and looking to put their own portable modular nuclear reactors
I saw
in
that.
order to power those processors. Yeah.
Yep,
Yeah, what a brave new world for sure.
it is.
Yes.
Absolutely.
In the early 90s, we'll roll back again,
Here
you were developing multi-process SCADA systems. How does the complexity of those early systems compare to the factory floor to enterprise connectivity that you design now? Speaking of Industry 4.0.
if you were able to pull up a graphic and look at 3.0 to 4.0, the graphic is about the same, but there's usually like an iterative circle at the top, and it shows the whole cyber physical part of it, being able to utilize and leverage the computing power. The stuff that was invented, implemented, excuse me, put in place in the 90s is kind of the foundational step of where we are now. Being able to have the sensors in place, being able to have the computers, the networks, the PLC systems to be able to pull and extract that data, put it into edge computers, put it into the cloud, being able to suck that data up and use it had to start somewhere. And again, if you look at the definition of 3.0 to 4.0, it is really implementing the analytics, being able to bring the analytics back to the floor and provide better working methods using that data.
The entire conversation we're having, I keep thinking if someone from 10 years ago were watching this and listening to this, they would have no idea what we're even talking about, right?
Yeah.
Yeah,
Yep.
that you're right. I mean, how the tech in 10 years, the technology has just shot forward.
One of the things, Mike, it's interesting. at Paxis, the company I owned before coming to AGR, I had a group of talented engineers that worked for me, and we sat down one day and being a systems integrator, everything was custom, everything we did.
Sure.
And we kept coming across a common theme. And this is back in the mid to late 90s, early 2000s, where 2004 was kind of a good number, where we
Hmm.
saw a lot of customers looking to start pulling data and being able to, or wanting to know what happened during the day. How much raw material did they use? How much downtime? What was the OEE? They started looking. So we said, I'm tired of doing things over and over again. Let's do a product. Products are profitable. Let's do a product. So we put together a little, for lack of a better term, a little blade server that had an industrial PC. You might call it an edge computer today. It was an
Hmm.
industrial PC. It had a database on it. We had some very standardized I/O methods to be able to pull information from the field and store it. So you would ask the question, what's the difference between today and then? Um, I think again, I think it's a foundational thing and it's a growth. But a lot of this stuff, quote unquote, started with that being able
Hmm.
to have a database, have an industrial PC, and having the avenue to pull information from things like PLCs and sensors that existed on the floor.
Right. Right. Well, speaking of Paxos, you that was your company. You took it from a single person operation to a multi-million dollar company, right?
Yes.
Was what would you say was the most difficult technical hurdle that you faced while you were trying to not only manage the technical side of the business, but the business side of a startup?
Probably three things come to mind. One is it might be a little bit of a stretch to say technical, but finding qualified help even back then.
Sure.
Trying to find engineers that had this forward-thinking mentality of thinking about the data aspect, not just the PLC, being able to do networks. We had one customer that had multiple lines, and we got it to the point where we were doing VLANs, where we had every line set up identical and then used networking to be able to pull data kind of
Hmm.
efficiently. So
Wow.
having good qualified help was kind of a hard thing to find. If I had to say there was probably a technical hurdle, and it goes back to the journal or the magazine you talked about,
Hmm.
um, the non-standardization and inability to gather data from various machines.
Mm.
Um, things were RS-232,
Hmm.
RS-485.
Right.
They were token ring, they were control net.
Right.
So you walk in and you try to figure out how to do what we want to do with data acquisition and data monitoring.
Hmm.
It was very difficult at that point. You
Hmm.
had to try to figure out, you needed something with an OPC server or some sort of driver to be able to do
Yes.
it. It's still that way to some degree today,
Hmm.
but with OPC UA, MQTT, hub publication and subscription, pub subs,
Right.
you have the ability, a little bit better ability to grab the data.
Hmm.
Um, other than that, it was more kind of the rudimentary business part. Being an entrepreneur, not only are you technical, but you got QuickBooks or whatever it is that you have to worry
Right.
about. And how do I have a cybersecurity because I'm hosting my own website? I've got an email server in my office. How do I keep that secure? Before I hosted my own server, I once contracted my email hosting out to a local company who then contracted to a larger, I guess you could use a contractor or a larger company that did the infrastructure. It was
Uh-huh.
based in Baltimore. And Baltimore had a construction accident where a backhoe or an excavator, whatever it was, chopped a large fiber bundle. I
Oh,
was without email for a week. Uh,
wow.
and when your main means of communication is email, wow, did that hurt? And I didn't realize
Yeah.
how much it hurt until
Right.
what are the hardships? I think those are kind of I can't look back and say it was PLCs. No, I can't look back and say it was computers. No,
Yeah,
I think it was kind of the age old people and the ability to get the information and then the systems, business systems.
right. Today, not having access to email, I mean, you have to be on a remote island somewhere in order for
Yeah,
that to be, because you can just get it on your phone now.
absolutely.
But yeah, kids today would probably have no idea. Like, what do you mean you couldn't get your email?
Yep. Yeah. It's funny. Everybody has one of these.
Right.
If you set these things up right, I can literally do a day's work anywhere because I have Teams, I have OneNote, I have
Yep.
Word, I have everything on this phone.
Yep.
With the network capability, there's nothing I can't do
Right.
on
Yeah.
that.
Yeah. 100%. 100%. So let's talk about your patent
Okay.
for a bit here. You hold a patent for a pharmaceutical bottle inspection system from the 90s as well. The 90s was
Yep.
a very productive period for you. Was there kind of like a light bulb moment, an aha that led you to that specific invention?
What's the saying? Necessity is the mother of invention. At that particular point in time, I was part of a company based in Stamford, Connecticut. I ran the North Haven office or had my engineering facility in the North Haven office. And one of our customers in the New Haven area was an FDA facility. And
Hmm.
the FDA at that point had put out a pre-release of an FDA mandate that basically said any pharmaceutical bottle that has printed date and lot code information at that point needed to be 200% manually inspected, meaning it needed to pass two people's eyes,
Right.
or 100% electronically inspected vision system.
Hmm.
Um, a lot of companies at that point already had full packaging and bottle filling lines. They had pre-printed labels they were putting on, but the mandate was once it was applied to the bottle, it needed to be inspected before it went out the door. It could be printed and inspected. That wasn't good enough under that current code that they were proposing. They
Hmm.
wanted it on the bottle. So customers came to us and said, "Hey, can you?" So we put together a machine that basically you could take and slide two pieces of equipment apart, slide a machine in that's probably the size of a desk or smaller. It would accept the bottles in, it would rotate the bottles until it found the edge of the label,
Hmm.
and then it would index to a known position, and we would take images of various aspects of the label. We looked at raw material number on the label. We looked at the date and lot code, a bunch of things. So anyway, as the bottle went around, it was either accepted or rejected. Um, the thing that was cool about it, if you wanted to call it an invention, and this is where I loved what I did. Um, this was before AMCI and Applied Motion had servo motors with drivers built into the bottom of it.
Okay.
You could buy small servo motors that drove turrets. I
Hmm.
had to, for lack of a better term, invent. It really wasn't. It was design a small PWM servo controller that went for the ride with the motor, and it rode on a full turret on a full dial. So the
Okay.
as the bottles came in, it would index around the dial. So all of that was designed and implemented with an RS-485 network, so I could communicate to every one of the controllers and pass information back and forth about whether the bottle was found, not found, all of that.
Hmm.
And so that was kind of a cool thing. We actually, because it was Allen Bradley CVIM when Allen Bradley was still doing vision, it was Allen Bradley PLCs, Allen Bradley servos on the main dial. It was a lot of equipment from Allen Bradley, and they really loved what they saw. So they actually sponsored that machine to go out to Pack Expo in Anaheim,
Oh,
and we demonstrated that machine. So it was
awesome.
a cool thing.
Right.
It was, but because it was different, um, and since then the FDA changed their mandate. That is not really, they still want that inspection, but not to that level. So
Right.
while the machine was patented, it was kind of a short-lived machine, unfortunately.
Sure. Sure. It was, and then was that? were you designing that for a specific customer at the time, or was that just in anticipation of this and that if you build it, they will come?
They will, yeah, exactly what you just said. If you build it, they will come. It was because the mandate said that you needed the 100% inspection on the bottle. There was nobody out there that did on the bottle inspections because
Ah,
bottles are randomized at that point. You know, you could be
right,
filling them. So we had to orient the bottle and inspect it. So it was a specifically pointed machine for the need that the FDA was kind of mandating.
right. Let's fast forward a little bit to Arthur G. Russell, where you still are.
Yep.
There, you grew a department from 5 people to 20. And I know developing the next generation of workers is a very important aspect of what you do. What specific soft skills? I mean, the technical skills are semi-obvious, I guess, but
Yeah.
what kind of soft skills do you look for when you're hiring a controls engineer that you might not see in when you're reading their CV?
The ability to work in a team environment. And sometimes you can't know that until they're on the floor, but being able to think on your feet when you're needed, being able to communicate. One of my questions, I don't want to give my interview questions away here,
People will
but
start taking notes.
yeah, exactly. One of the questions is if you have multiple conflicting priorities, how do you handle it? What do you do? I ask things about how you would organize your day based on information that you have with the jobs in hand. So what I'm looking for is the critical thinking aspect,
Hmm.
and it's kind of funny. You can um, people there's a debate on whether you can teach critical thinking or not, or if it's innate, but that's kind of what I'm looking for. One of the questions is, hey, if you have this, what would you do, and tell me why. Not just what would you do, but tell me why. I want to see the thinking behind it.
Right.
So it's kind of being able to, none of my team work individually in a silo. If the projects are small, there might be less of a team, but they're still a team. They're never all by themselves. In the larger projects, I have a lead position. That is a role. They kind of coordinate all the other supporting roles like vision or HMI or things like that. So being able to communicate that information to various levels, the same information that they take, they have to give something to the project manager, perhaps the president, to me, to subordinates, to team members, to whatever. You've got to be able to change that message. And I'm looking for some of those skills to be able to understand how you think on the fly and how you can work with various personalities, if you will. Those are
Sure.
probably the biggest things that I look for as soft skills.
Right. Yeah. Yeah. Very important skills for sure.
Yep,
If you can't work with a team, that's going to cause some issues.
correct.
Um, so and then what about your teaching as an adjunct faculty member at 2 different universities? What's the biggest gap that you see between what students learn in a robotics lab and what they encounter in the real world on the factory floor?
Um, One thing that's interesting that kind of goes along with what you're talking about is when you and I were in school, notebooks and note taking was a thing.
Hmm.
As I'm teaching class, I see 10%, maybe 20 of the students actually taking notes. They're not recording. They have the slides that I put up and they just sit back in the class and listen. So I either take that as that they have great listening skills or they're counting on going back. But the the ability to take and take notes and extract strong pieces of information out of the lecture, out of the presentation. Um, I don't know if it's lost, but it's not the same as what it once was. The other thing is in our industry and what we do, relay ladder logic, for instance, is a graphical language invented in the 60s by Matacon, specifically invented because the only people who knew what it meant were electricians. They knew how to read schematics. So
Hmm.
when they invented relay ladder logic, it was mirrored off of electrical schematics. So what I'm seeing from a lot of students right now is, geez, this would be great if it was scripted. This would be great if it was Python. It would be great if it was Java. So
Hmm.
throughout all of their time from middle school on, I'm sure they've had Arduino programming or Raspberry Pi. They've been at the computer doing this coding in
Hmm.
either an object-oriented fashion or some scripting language. They're more familiar with that. And I think this is my prediction, may or may not come true, but I think what one of the things that is going to be happening in the next 5 to 10 years is RLL, relay ladder logic, kind of sliding away a little bit, still there in order to do the whole IEC, the three language mandate. But RLL is going to slide away, and you're going to see more of the code assist and the open PLC type of environments come up because that fits more into what the students have seen since they
Hmm.
were 10, 12
Hmm.
years old. Everybody's used to joysticks and everybody for
Right.
gaming and things like that, all
Yes.
the new students. So um, when they go into the lab, they're going to want to kind of do that same thing. They want that interaction. So one of the things that I see it being in the classroom, trying to go away from a lecture oriented thing to more of a hands-on.
Hmm.
Last year, when I was teaching a graduate level class at UHart in Industry 4.0, I changed the class. What I did is I said, here are the 9 pillars of Industry 4.0. We're going to be doing this software, this software, this software. We're going to talk about sensors. And here are and it was more of a hands-on. And the final project was I broke the class into teams, and every team had a portion of the project. Team one output was the input for team two, let's say.
Yeah.
So they were able to kind of work in a department or interdepartmental thing,
Right.
but it was hands-on. My point is that it was getting away from the lecture. I had feedback from past classes that said it would be cool if this was hands-on. So
Right.
that's what I'm seeing.
Yeah. I know when you mentioned about the languages and the younger generation with with the higher level languages, I think we had talked about this before actually with the advent of artificial intelligence and its ability to not only translate from one language to another, but just taking natural languages
Sure.
and being able to turn that into whatever, pick a code.
Right.
And with artificial intelligence has that capability. Do you foresee that becoming even the next, now we're talking about higher level languages, but is that going to be like a passing phase, like a CD has become, where yeah, that was a transitional step, but now the language itself is immaterial.
It's funny how the worlds collide and things kind of intertwine. One of the gaps is being able to code, being able to do PLC level languages and everything. And my dissertation was being able to use genetic programming to self-write PLC code. So genetic programming is a facet, it's a small facet, but it is a facet of AI. Put that aside, in the last 2 years since then, since I wrote my dissertation, there is a big emphasis going under with multiple companies who are using large language models to be able to say, okay, here's a PLC code. I'm going to rip it apart in AI. Here's what I really want it to do and put it back together.
Mhm.
Or the way that I'm looking at it is if I feed you all the libraries that I have and I tell you what I'm looking for, put together the program using the same structure that you see in these files, using the
Mhm.
same tagging conventions I see in these files, and but I want it to do this, this, and this. And I think we are almost there. I think we're within
Mm.
a year or two of having that level of interaction, which will help with the skills gap. It will allow people to use that as a tool to deploy faster And because you're going to be using debug code for the most part, I know that there's going to be a bunch of people saying, no, you're not. I understand. There's going to be some debug because it is new code, but you're using libraries of known good debugged, structured, formatted PLC code.
Right.
So to answer your question, I think it's the next wave. We're really close, and within a year or two, we'll be able to have something like ChatGPT write our PLC code.
Wow, within a year or two. Yeah, that's it'll be here just like
Yeah.
that.
Yep.
Yeah. Your students, you've developed specific degree curricula um, with the universities in order to mitigate that skills gap, right? Uh, what would you say is one skill that every new engineer should have that maybe isn't currently being taught enough?
You can try to emphasize, you can try to show how critical thinking might be done. And going back to one of your first questions, um, troubleshooting is a critical thinking task. Uh,
Right. Yeah,
and
absolutely.
being able to do that, I think is the big thing. There's several other skills that I think students need. Here at AGR, I've got a skills matrix with 45 discrete skills that I write down.
Right.
6 or 7 are specific to us. The rest of them are not. Vision, PLC, HMI, things like that.
Hmm.
So some of the things that might be important other than critical thinking might be the IT, the networking, cybersecurity, data acquisition, databases, data analytics, of course, AI. I like the way that bachelor degrees provide a well-rounded base.
Hmm.
You get the calculus, you get the physics, you get the dynamics and statics, you get the um, within the realm, you get all of that thinking that helps you with other things. So I'm a control systems engineer, and you're going, why would you care about statics or dynamics? Because I now know things about torque on a motor, and I know what the inference of that is to current, and I know what then that is to what an SCR or a MOSFET. Walking it down and having that knowledge is helpful. Um,
Hmm.
if I could offer one thing, never take differential equations in a 6 week summer class. Um, right after I got my associate's degree, I flipped over and was going for my double E. And what I said to myself is, I'm going to do all my maths. And at UHart in the double E program, they had 5: Calc 1, Calc 2, differential equations, calculus of several variables, and advanced engineering math. So I was trying to get through them semester after semester. And I did differential equations in a 6 week summer class, 3 hours a day, 4 days a week, six
Oh,
weeks. At the end of Thursday, I was fried.
I'll
So,
bet. Yeah.
anyway, I digress. But you asked for one, I think critical thinking. But if I can emphasize to the students out there, it's important to have the well-roundedness, some of the humanities, but physics and calculus, I think, augment the base knowledge of everything you're going to see on the factory floor.
Right. Okay. And that matrix, I know you've at least mentioned it at some of the presentations you've
Yeah.
done at CSIA. Have you ever actually given a presentation on what those 45 skills are?
No, I popped the matrix up and it's a little
Right. Yeah.
inset of
I
it,
remember
and I
seeing it.
probably show a dozen. No, I have not. No. What I tried to do is I sat down and said, okay, for my guys on the floor, for me personally, I was a systems integrator, control systems engineer for all those years. Looking back at what we do here and what I've done, what does a typical control systems engineer need? And
Right.
I just started writing things down. And at that point, we were probably like 36 or 38. Then came Industry 4.0. And now you start adding data analytics, AI, databases, networking, all of the things that are computer science sort of related.
Hmm.
But really, a control systems engineer needs to know how to take data from the factory floor and put it
Absolutely.
so we're in a structured manner where somebody can use it.
Am I wrong in thinking you use it not to assign people the things they're good at, but to fill in those gaps?
A little of both. Great question. So the first thing I do is when we hire somebody, we sit down and say, okay, each skill has a circle, and the circle could be empty, quarter full, half full, three-quarters full, or completely full. Um, as the epitome of a control systems engineer would have all 45 skills completely filled in, and that
Right.
would be great. Um, while we're not so large that I can't just remember what this person has for skills,
Hmm.
but it's nice to be able to go back and say, okay, this person needs some work on robots. The next time I get a robot, I will assign him along with somebody else that can support and bring up his skill level on that, or send him to training, or a
Right.
combination of both. But then being able to try to keep the training of everybody up to snuff is kind of the major part of it.
Sure. Yeah. Great idea. Great matrix. All right. Well, let's talk about a little bit about your military background. As a major in the U.S. Air Force Auxiliary, thanks for your service,
Thank you.
and director for Aerobridge, how did your experience with disaster response um, and military structure influence your engineering project management? Let's talk about your project management skills.
Um, that's a really good question because they are, I don't want to say the same or synonymous. They have a lot of common skills. Um, being in disaster relief and rescue missions, there's always, in fire departments have it, ambulances have it. There's an incident command structure, and there's several levels of incident command. But the structure of incident command is similar to that of project management. Being able to think quickly, being able to think in a regimented format of how this is done and why it's done. You
Hmm.
don't go down a track that's not proven and might cause harm to other people, or sacrifice lives or something like that.
Right.
In the rescue part of it. So once it's established and you're trained on it, you continue to use it and practice it. We would do what were called SARXs, search and rescue exercises, several times a year. I'm a pilot too, so I would fly some of the missions. I would be on the ground team. I was a approved ground team member, so I would do both sometimes on the SARXs. But you had to react and work within that incident command structure and know who to take information from, what the chain of command was, and things like that. Same thing with project management. Here at AGR, we have a director of project management, and then we have several project managers that manage the individual projects. My lead role for my engineers, if I've got a large project, my head control systems engineer has had training, one of the skills matrix, in project management. Are they a project manager for the company? No, but they have the ability to know what the project manager is going to need there
Mm.
for budgets, for time schedules, Gantt charts, things like that. And being able to formulate that message and take the data from the project and give it to them is important. So I think they kind of come together. I think some of the things that come out of that is leadership from the military side of it, leadership,
Sure.
discipline, respect, um, being able to work within a system like we talked about, and again,
Mhm.
being able to think on your feet is kind of an important part of it.
Are there other paths that you might even recommend to someone who doesn't have the opportunity to not have their financial aid come through as you're about to start your bachelor's degree and you have to pivot?
Um, yeah, wow, a lot of answers there. I'll try to keep it as brief as I can. The I guess one of the big things is lifelong learning. Um, no
Sure.
matter what that is, whether you start off at a high school, a technical high school. We had an analogy here. The ex-president, the retired president here at AGR, used an analogy of a train and train stations. You can get on the train out of high school and you can get off at the first stop. And the first stop might be an associate's degree. It might be the technical education. If you want to get back on, you get back on the train, you go to the next station. You may want to do your bachelor's and so on and so forth. For me, it was a means to an end for every one of them. Not everybody's going to do what I did. Owning my own company, I saw the writing on the wall early on, and I wanted to be the best at it. I have a personality flaw. I don't like knowing less or not knowing more than anybody else. So if there's a subject matter that I like, that I'm passionate about, I will learn everything I can about it, and that might be part of it. My wife kind of giggles about that all the time. But the 5 degrees I have, the first one was out of that's what I wanted to do. I knew electronics and computers were going to be my thing.
Right.
Happenstance. My mom worked for an answering service and answered phones for a company that was called Temperature Controls for Industry at the time. He
Wow.
needed a grunt. I went and interviewed there, and being a grunt for a couple of months, I also noticed that there were some instruments that weren't being fixed because they weren't the favorites of some of the other technicians. I asked one of the other technicians, why aren't those being fixed? I had some slack time. So he showed me what they were and how to work on them. And having electronics through high school, I was blessed there. I had 4 years of electronics coming out of a
Nice.
public high school. Um,
Wow.
but I was able to fix things. I was able to do it. So I became a bench technician within a couple of months. I pivoted, like I said, after my associate's degree, bachelor's degree, double E. Life gets in the way. I stopped short of my bachelor's degree, and I didn't stop there. I kept doing some continuing learning. But when my oldest daughter got to the age where she was going to be graduating from college, being an athlete and not wanting to be beat and being competitive, and that's a joke, but not really. Um, I The writing on the wall at that point was for data, being able to look at what people were doing on the floor, being able to do networking. So I put the double E. I was a senior status at double E. I had just a couple of courses left. I
Mhm.
pivoted and went to an information systems background. And I did that specifically to fill in the gaps of what I was seeing at my company. Then I remembered how much I loved learning, and I went for my MBA. I'm sorry, my master's of science in computer science in modeling and simulation, and that was what is now considered the digital twin. And I did again that for a reason. I saw the writing on the wall and things were going. That was back in 2011. I started 2016. I ended that degree. Then I went for my MBA from 16 to 18. That was because of I wanted to be a better manager here. And I also wanted to know more about data analytics. So that's why I did that. And then again, wanting to expand horizons here, research, publish. That's why I did the PhD. Long answer, sorry. Everybody is going to have a different path. Everybody is going to want to get off that train at different stations.
Mhm.
If you're satisfied and completely content with where you are, that is perfectly great.
Mhm.
All I ask is that you be that lifelong learner, because when that new servo motor comes out or that new AI part of it comes out, you're not going to want to be left behind in this industry. You're going to need to know what that is. So always go to the webinars, go to the CSIA conference, go to ISA. ISA's got a bunch of stuff online that you can get, and they're short courses. I know CSIA has things like that as well. There's
Mhm.
webinars and seminars everywhere. I think your live website has links to some of those as well.
Right. Yeah, absolutely. Lifelong learning is such an important part. Like you said, I mean, even this conversation that we've had here, how many times have we talked about 10 years ago, this didn't exist? And if you're not keeping up to date or if you're not learning new things, you'll still be right now you'd be stuck in technology from the 90s.
Right.
Can you
Yeah.
imagine that? You'd be
Yep.
out of a job for sure.
Exactly. Yep.
Yeah. Yeah. All right. Well, I thank you so much for spending this. I always enjoy talking to you, but thanks for spending an hour uh, talking with me here. Great, great advice, great stuff. Always a pleasure speaking with you.
Same here, Mike. I appreciate it. Thank you very much.